Okay, next up we have Miruna Clinciu presenting Taming the Black Box, Explainable AI for One Health.
So, hi everyone. Today we'll try to understand more about this new field, right, for many of you, explainable AI. And I try to make that funny thing there, Taming the black box, because actually we don't really know what's this black box. But I'll try to give you some insights and at the end of all this presentation to have an idea. So actually I want to highlight what it's actually explainable AI and why it's so important for One Health. I will try to highlight that trust is very important, especially when we try to use artificial intelligence. What is this black box? And also, what is the right explanation? We've seen already that a lot of people add the GDPR, but actually it's more than that. And we do have some methods to actually explain how artificial intelligence works. Yes, of course, we need to improve them, but we still have something. And I also want to highlight that at the end we do have also natural language explanations. We have these large language models and generative AI, and that might be a link between artificial intelligence and humans, both experts and non-experts. And of course, I will have some conclusions at the end, and I hope you will have lots of questions. So what is artificial intelligence and what is explainable AI? Explainable AI, it's actually a subfield of AI. It's a research field that tries to focus on how we could understand how artificial intelligence models works, how they are making their decisions. And yes, we cannot say just because I said so when we have some results, that's quite difficult sometimes. But One Health needs artificial intelligence, does need explainable AI. Well, One Health, as far as I find from everyone, it's a connection of people health, animals health, and the environment health. And if we think about all these nice projects that everyone shared, we do have a lot of data. We have big data, and artificial intelligence can help us maybe identify some patterns, some relations there. And we can go even more. If we take some examples, healthcare. If an AI tells a doctor, this patient might have the flu, we don't really know why. Should we trust that? Or if we speak about the animal health, an AI will predict some chicken flu, right? But what will happen if it's biased? Can we speak there about Federer's conspiracy? So it's quite tricky. Now, this is just a funny case, but sometimes it might be quite worrying. So explainable AI will help us actually to see the reasoning behind all these artificial intelligence models and how actually they are making their decisions. So we do have here doctors, veterinarians. We also have public health officials as well. But do you trust artificial intelligence? Do you take its advice as it is? That's interesting, right? But we need to trust it. So how we could trust it? Of course, we'll need to understand how AI systems are making their decisions. Are they fair? Are they reasonable? Are they transparent? Do we have any hidden biases? What is with all that mysteries that's surrounding AI? And actually, this is the black box. It's like a magic trick because we have some input there. We have an output. We could see that's nice predictions, but what's happening inside? So we don't really know its internal workings. I mean, depending on what kind of AI we are using. And we will see that as well. But what is the main problem with the black box? So there are some questions that we are asking ourselves, right? Why did AI make this decision? So we have some transparency issues there. Or what about fairness? Does that decision is fair enough or not? Reliability. Can AI make correct predictions consistently? Also, ethical side and accountability. Who is responsible when an AI will make a decision? So we will need to actually figure this out as well. But also we have the security and privacy, which is also very important. Is my data secured? What will happen with all this data that is used by AI? And I'm not from your field of research. I'm from artificial intelligence, but I try to collect some examples randomly. first search on Google. And the first AI model that I found was actually Blue Dot. So Blue Dot, it's able to analyze airline data, news reports, medical records, and through all this cycle, it can detect some infection outbreaks. Actually, I find out a success story of this product detected coronavirus outbreak days before the WHO officially announced it. Now, if we think about this, right? Can we trust it? What if we will use, for example, Blue Dot? What about some predictions that are made from all this data? Now we need to think, is medical data, is news data, or just some reports, is randomly connected from the internet? We cannot trust it, right? But we can go even further. Can we make some, I don't know, policy decisions? Can health officials say, okay, we will have an outbreak in the next 20 days? We cannot trust it without more information. But we also have maybe IBM Watson. So IBM Watson can actually diagnose diseases like cancer, and the success story is actually offering quite good treatments in specific cases. And again, we speak about a patient that might have cancer. You cannot just tell your patient, you know, you have cancer. What if it's wrong? What we have, for example, a false positive. So in all these scenarios, we need to actually have a clear evidence from our AI models. Or if we cannot do that, then we also need to look at their predictions and also consider that human in the loop concept. We should also give our approval, not just rely on the AI models. And another interesting one actually was Google Environmental Insights Explorer. So we have air pollution, satellite data, carbon emissions, deforestation, and actually they try to help cities design greener policies. But again, what if we have some missing data? How we really know how we end up with pollution in a specific area? Because there we might have industrial activity or temporary weather pattern. So we need to know exactly what's happening. But we have this right to explanation nowadays. So as users, if we will use artificial intelligence, we also have the legal and ethical right to know why we have a specific decision. And I actually extracted this little example. If you use an AI, which will be a black box, in general, neural networks, deep learning, we will have this sentence: cattle farm at risk, immediate quarantine required. Just having this, you might not trust it. You want to find out more. So you start to put some questions there. Why, how, what? I don't know if you've seen, but actually in my presentation, I tried to bold these questions because they are very important in the field of explainable AI. And I ended up with this big explanation, and actually I did use the large language model for this. I'm not speaking yet about them, I will speak about that as well. So we could see that it gives us even more description. Of course, when I generated this, I give more details as well. So we might have a rise in similar cases in nearby farms and environmental conditions, so humidity and temperature favoring disease spread. So quite important. But we have the right to explanation, and this started with GDPR in 2018. After that, actually, everyone started to think about all the implications of artificial intelligence and how this can affect us. So we also seen other global efforts like China or Australia, but quite recently we have the AI treaty that was actually signed by US, UK, and European Union. So actually, the legally enforceable AI treaty for AI transparency and accountability, which is quite important, right? But I spoke about this field of artificial intelligence and explainable AI, how you could use it, not me as an AI expert, but in your own field. So I extracted some methods, and I believe, or I even heard actually, that many of you already use them. So for example, feature importance, and actually will be one of the first that I speak about. But before that, I want to highlight that we do have different artificial intelligence models. There are different categorizations. You will hear about symbolic and subsymbolic AI. So symbolic, you know something that's happening there, or subsymbolic, you don't know, like neural networks. After a while, you don't really know the math behind all these models. Or a different categorization, if you think just about their prediction power, and also their interpretability, we can end up with the graphical representations like this one. And you consider we have classifications rows which are highly interpretable. We do know the math behind it. We have a mathematical equation there, and we can say step by step how we end up with a decision. But if we go further, for example, graphical models, we still have some idea, but we jump to support vector machines, kernel-based models, we started with a gray area. We go to that black box. So as you can see, the predictive power also increased. Of course, deep learning neural networks might give us better accuracy, better predictions, but also we have some drawbacks for that. They are not explainable. I also want to highlight here that there are a lot of terms that we do use interchangeably. So we have transparency, interpretability, and glass box. So there are so many terms that actually we use. But that doesn't really matter. If you know that some of them can tell us something about their decision, that's very important. So I said that we have different methods, and the feature importance score actually were used by many of you, and they actually can show you exactly what variables or factors contributed to a specific decision. But we do have attention mechanisms, especially in neural networks, that actually can highlight the parts of the input in AI that was actually mainly focused on the final decision. We have saliency maps as well, so these are visual explanations that will tell us more about how AI ended up with a decision. I don't show you just that bullet points, I will show you some graphical representations as well. So I actually try to find examples from your field. And I find this research paper, Supervised Machine Learning Based Ensemble Model for Accurate Prediction of Type 2 Diabetes. Well, it's not quite the field of everyone because we have more vets here. But as we could see here, just from this graphical representation, age and systolic blood pressure average actually have quite a high importance. So if you plot something like this, you can figure out what's happening maybe at the end of your decision. But we could go even further. So we could identify actually, for example, for lung disease using just X-rays, what exactly parts of an image will tell us the contribution to a final decision. I won't cover all this, but the research papers are there. I think they will explain it step by step. We do have two agnostic models that can be quite easily used. There are existing libraries and you can just call them. So we have LIME, locally interpretable model agnostic explanations, and also Shapley values. But what I want to show you here, it's a very quick scenario. Imagine you have an AI model that will predict whether a person will get sick based on different factors. For example, age, diet, or pollution levels. If you use LIME will tell you something locally. So we'll focus just on maybe one individual. John will likely get sick. And actually the data will look something very similar with this, but you want to actually predict if John will have the disease or not. You do have the age, diet score, and pollution level. Of course, your data can be even more complex. But you will end up with some graphical representations like this one. So sick, not sick, features. You don't really know anything about it at this point. You will need to even find more about this graphical representation. So keep that in mind. If you use Shapley value, game theory will try to allocate some contribution to each features that we have for a final outcome. So in this case, imagine that you will have, for example, zoonotic disease outbreak based on some specific factors as well. Again, a classification task, you need to predict something, your data, but you'll end up with a graphical representation similar with this one. So we have there f by x is equal with 0.614. So actually this is the percentage that actually will influence to that final outcome, if a person will have a disease, if it will be infected or not. However, in this case you have the whole features. This will be considered globally. So we'll take all the features in consideration and see what are the ones that will actually affect your outcome. But again, I need to give you actually a presentation for all these graphical representations, right? I need to explain what it f by x is the prediction value, what is that percentage, what is the chance of infection, and so on and so forth. And actually, when I'm doing all this, I use natural language. And natural language actually, it's a quite intuitive medium of communication between us as humans and computers or artificial intelligence. And actually, it's very important to communicate difficult decisions, complex decisions using natural language. So maybe sometimes we don't have this interpretability, but we can figure out how to extract all this information and explain it. But how actually we can generate natural language explanations? And of course, everyone heard about these large language models and OpenAI. And yes, we could generate natural language explanation just actually creating an API and calling, for example, OpenAI. But there are so many other large language models that we can apply. Gemini, Llama, Claude, so many. Now, even before that, we have natural language processing and generation. Imagine that you have all that scores from Lime or Shapley. You can extract that information and maybe create some summaries. Some summaries that, if I remember correctly, someone, maybe Jill and you, specified that gold standard. Hey, we have something similar here as well. We need the gold standard for explanations. What makes a good explanation? Now, depending for everyone's case, you might have different gold standards. And you could compare that with what will look your generated natural language explanation. So yes, I say generative AI. Of course, we will need to think about this black box model now. We have this prediction, 87% probability of zoonotic disease outbreak. So now my problem, why 87? What factor contributes to this prediction? How can public health officials take action? And yes, we do have generative AI. It can be very useful, but as you also observe, we could have hallucinations, so these errors. Not always they give the right responses, right? But if we train them, and we are able to train them actually, they can give us some good results. Now, I'm not speaking about training because it will require lots of data, but we can do fine-tuning. We do have some specific methods as well, and that can be very useful when we actually create our prompts. So we could learn over time through prompting how to actually generate something good. Yes, so we need to think about these templates depending on the case as well. So here actually I do have some generated explanations using large language models. As you could see, they are quite good. So increased livestock density by 30% in the last 6 months. And to be honest, this started to be quite good as well. So they don't have that mathematical errors anymore. We do have benchmarks for this. So they will actually increase their capability over time. But what I highly recommend, still we will need a human there in the loop that will agree or not with all these predictions as well. So natural language explanation work or not? Why? So they try to explain our AI decisions. They provide sometimes contextual insights as well, so we extract that information from Lime and Shapley. And also, it can be quite good for actually the healthcare system. So what makes a good natural language explanation? We do need evaluation. And this is a different topic. Actually, this is my research field as well, how we evaluate these natural language explanations. Depending on the case, you might want more information, or you want have to be quite clear. So depending on the dimensions, how we name them in natural language generation, you can actually influence the generation of them as well. So some conclusions, of course. AI for One Health can help us to personalize medicine as well, and this can be done through explainability as well. Explainability is a black box, but we do have methods that can help us to have a better understanding. And also, natural language explanation make AI decisions clear, actionable, and interpretable. Now, it will depend for everyone's experience as well. So yeah, that's everything. Thank you all.
Any questions for Miruna? Or sorry, Miruna?
Miruna.
Yeah.
Yes.
Hi, I'm Jess Unright from University of Glasgow. I enjoyed your talk a lot, thank you. I mentioned earlier I was at AAAI last week, and the presidential address she was very big on the idea that we can in some ways perhaps overcome the black box nature of agentic AI, which I find deeply suspicious, by kind of somehow combining those things with your more interpretable, explainable, reasoning-based approaches. What's your opinion? Do you think that's possible?
So actually, there are some prompting techniques that can help us to identify how, for example, a large language model ended up with a decision. So it's, for example, tree of thought. You will need to think about a succinct step, like a succinct plan, and try to see how your AI ended up with a result. But there are other methods as well that I didn't actually cover because I was thinking they might be for a different field, for example, distillation. So you can see exactly what's happening at a specific point in a large language model as well. Now, there are other issues that we should take into consideration, for example, biases, how we actually identify that biases. And we can, because it's more linguistic, we can think about stereotypes. We can go even further, think about different regions. So everyone is adding their own biases, their own stereotypes as well. And we need to first maybe identify that and after see exactly what's happening there. But regarding the reasoning, that's a very interesting topic as well. And I believe everyone from the linguistic field actually are studying little parts from everything. Causality, it's again something very important linked to explanation because you have A cause B, therefore you need to generate an explanation that will be maybe causal. And again, there are different types of explanations as well, but if I had to speak about everything, I think, it takes a lot of time.
Thank you.
Yes.
Is that okay? Hi, I'm Lise Bowden from University of Edinburgh. I also really enjoyed your talk, and one of the things that I was really intrigued by was that early on one of the slides you said we have a right to an explanation. And the language of rights is legal language, and it sort of made me a little intrigued as to where you think those rights sit, at the level of the individual or the collective. And if it were at the level of the individual, I suppose if you decide that that is a right to an explanation, you don't get that explanation. We often give up many of our rights at individual levels for collective responsibility in, for example, agriculture and outbreak response, because of the nature of emergencies, public health emergencies. So I'm just curious how you reconcile all of that together in the language of rights, which would be, there's something interesting there.
I think it's a very, very good question. So, I said keywords as well today, expert and non-expert users. Now, we will need to think to whom actually we will provide all these explanations and actually what they want from us as well. Speaking here about from the AI field. Because we need to know what they want. And we need to define, for example, that goodness of explanations according to different types of users. So it can be a collective as well. It can be an individual, but again, it will depend on the applications that we are creating. So this is how I see things.
So, and when you say we, you're referring right now, I think, to the AI
Community,
developer,
yes.
But perhaps it isn't where the responsibility sits in the end. Because maybe you're instrumentalized to do something for someone else, the government or whatever. So where does the responsibility at that end sit as well? It's interesting anyway.
So I also specified the concept human in the loop. Sometimes you cannot just end up with a decision. You do need a second approval. And of course, you will have an expert on a specific field. For example, here in your field, the vet, the doctors will have their maybe final decision and say, okay, I do have this prediction, let me check it out. It will be quicker for them actually to see maybe more features and how they contributed to a final decision and then make literally a check rather than actually look at the whole data and try to summarize that. So I think the time, it's very useful when we are actually using artificial intelligence. Yes.
Yeah, hello.
Any more questions?
Yes, I'm Anna from Roslin Institute. So, as researchers, but also medics and veterinarians that do evidence-based medicine will learn about hierarchy of sources. So you have meta-analysis, you have reviews, and all the various sources. So for us, it's not about how this works and why there is some answer, but where have you found it, so we can go there and see how valid is the source and how strong is this information. So when you have the explanation, we would need something to assess if this explanation is it a strong prediction or is it based on something weaker. So do you have any ways to address that in machine learning?
So depending on the type of model that you will use, you will know maybe know quicker how you end up with a specific output. For example, if you use decision trees, you will know how you ended up with a specific outcome. However, if you use, for example, a large language model, it will be very hard to, for example, identify all that resources depending on what kind of large language model are you using as well. I just think that was an update recently on OpenAI, and you can see sources at the end now. Now, it will be also your duty to start looking at that sources and try to figure out how you ended up with an information. But I don't think we should rely 100% on a large language model now when we have specific data that we should take into consideration. Actually, what I tried to highlight in my presentation was actually many models are using data from all over the internet. So how we know what's false or not? And we might spread even misinformation without even knowing about it. And I think you should think what kind of input data you use when you actually generate something. So everything actually starts from the data. How the data looks like, how we collect it, is it clean enough? And when I say clean enough, I'm thinking even at the bias part and any outliers that we might have there. So I think this should be very important. We have our data. We need to know our data depending on the use case and then end it up with that decision and explainability.
Yeah, and is there a way to get from even the language model, the prediction power or probability? Like, for example, they will say, okay, this is the intervention as was in 65% of the simulations, whatever, to get some number that tells me, okay, is it just random or is it like all the data it has indicates to this solution? Or?
So it will. So if you just ask, for example, on your browser, how you ended up with 65% from a specific, I don't know, like let's say of a numerical value there, it will just show you actually some sources now, and you will know how it ended up with all that decision. It's able to do it now, not all the large language model, as I say. But if you want to have a prediction, a good prediction, you do have your own data, right? You will need to figure out the math behind it somehow, because you will end up with a prediction in a way or another. You don't use a large language model to create that neural network. So there are some cosmetization, as I say, all that agnostic tools and even others that can help you to identify exactly where happened that difference. It's still a lot of work. It's still the beginning even for explainable AI. Everything started in 2018, 2017. I mean, it's from 60 to be honest, because Minsky tried to create something very similar. But from that moment till now, we didn't have too much change. We just started.
Ian McKendrick, BIOS. Thank you very much. This is a really interesting talk, and it's taken us into some of the places I actually really hoped we could get into in this meeting. What I would be quite interesting is thinking about the nature of some of the knowledge that we're potentially getting from AI, and obviously the explainability is a real part of that. I mean, my understanding is in terms of the philosophy of knowledge, there's a lot of the kind of view of justified true belief, that if it's going to be knowledge, it has to be true, and you've got to have a justified reason for believing it to be true. And then, of course, the philosophers get into a massive tangle as to actually what is justification in this context. And the question of how do we justify our belief in what an AI is telling us starts getting us into some really deep water. And of course, some of what you're doing there, what you've been talking about is, potentially you can see a world where we're using one AI to interrogate another AI to help us understand the validity of its evidence, which is, as suggested earlier, it's getting into real science fiction territory. But, I mean, how do we basically kind of navigate our way through this kind of philosophical morass? Is it feasible that we end up using AIs to interrogate other people's AIs to help us understand where they've come from?
It might be a solution, and actually thank you so much for adding all this, because it's so interesting. I was very interested actually in justification as well, reasoning, and even causality. Professor actually Judah Pearl is having a lot of research on this field, and I find it really interesting. That actually highlighted questions: why, how, what, were actually the beginning of how we could justify something, how we could create these explanations, and also try to think about some properties and attributes of explanations. For example, we should justify something, but what's the actual belief? What's our prior knowledge? Or what ended up to that outcome? So what caused that outcome? Again, it's a very interesting conjunction between causality, reasoning, even common sense. It's something that I didn't highlight it here, and maybe many of you will ask me, large language models sometimes are doing something wrong because they cannot actually understand our environment. And I always say this example, like for example, a kid will be able to use metaphors and associate, for example, the moon with a ball because they are having the same shape, where a large language model won't understand that our physical world. So in that case, when we speak about justification, it will be very hard to actually generate something without giving that prior knowledge as well. And maybe large language models are not containing all that prior knowledge. They are trained now, right, on some specific tasks like common sense, causality, and all these topics, all these tasks. However, there are fields that weren't covered, right? For example, the oil and gas industry maybe it doesn't have understanding of all that concepts, or the water domain, it won't understand, it doesn't know anything. So I already speak about engineering, but I'm sure there are even other subjects that are not covered. For example, genetics might not have a clear knowledge about everything. So we will maybe need to think about this as well, and how to integrate it in maybe these large language models, or going even further, trying to think about emergent structures, which is a different topic, but see it as a modularity between all these subtasks. Yes, so I hope I replied to the question. It's a difficult one.
Okay, thank you very much. That was a really interesting discussion.